Hey there. So today let's go over another pre-calculus topic that'll be handy in calculus, and that topic is binomial expansion. So first of all, what's a binomial? A binomial is a type of polynomial, and a polynomial is an expression consisting of coefficients and variables that involve only addition, subtraction, multiplication, and non-negative integer exponents. For instance, you could have x to the 7th, and then minus, so that's addition or subtraction, 6x to the 3rd, say, plus 12/5 x squared, right? So far we have coefficients and variables that are added, subtracted. We have multiplication here of the 6 and the x cubed, for instance. We have only positive exponents. I could keep going. I'd say minus pi times x plus 4 times e, for instance. Just a number, so that's just a constant coefficient or a constant term here, and here we have pi, just a number, as a coefficient for x to the 1st. You also could have many variables in one expression. For instance, you could have y to the 3rd, z to the 5th, plus 3 times y times z to the 7th minus 12, for instance. So this polynomial has 3 terms. This one has 1, 2, 3, 4, 5 terms. But what we're looking at specifically today is binomials, which means it has 2 terms. For instance, 4x plus 3 is a binomial. A squared minus b squared is a binomial. M squared times n to the 3rd minus 2 times q times r times s to the 5th. That's also a binomial. So those are just examples of binomials. So we can use this binomial expansion method to multiply out binomials in a quick fashion. For instance, x plus 3 to the 5th power. So normally you'd be like x plus 3 times x plus 3 times x plus 3 times x plus 3 times another x plus 3. That could take a while, kind of easy to make mistakes in doing that process, multiplying all these guys together. So we can use this process. First off, take a look at Pascal's triangle. So since I'm going to the 5th power, I want to use the 5th row of Pascal's triangle. So just want to remind you, as you build Pascal's triangle, you start with a 1 and then another 1 and a 1. And then as you build down from there, and again, we'll call this the 0th row. That doesn't make a ton of sense, but that's the top row, the 0th row. This will be the 1st row. And every row below that has a 1 on either end, and then you add the 2 numbers above it. So 1 and 1 gives me 2. This now is the 2nd row. For the 3rd row, you can see we have 1 on either end, and then 1 plus 2 is 3, 2 plus 1 is also 3, and again, we end with a 1. This is the 3rd row. Here's our 4th row, and again, each term, like this 4, is the sum of the 2 terms above it. 3 and 3 gives me 6, etc. That's the 4th row. So here, right here, is our 5th row. It's going to be the 5th row. Okay, so we'll use the 5th row to create the coefficients for our expanded x plus 3 to the 5th power. Before we go any further, though, why don't you practice making the 6th row? Here's a hint. Remember, there's a 1 on either end, and then you're going to take the sum of the values above it so that you can create that 6th row. Pause the video, take a second to do that, and then come back and see if you did it correctly. So hopefully you paused and you filled in that 6th row. Again, there's a 1 on either end, and then 1 plus 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6. Okay, so how do we use this to create x plus 3 to the 5th power? So x plus 3 to the 5th equals, and we need a little bit of room here because it's going to be a lot of terms that I'm about to write out. So this 1, 5, 10, 10, 5, 1, those are going to be the coefficients of each of the terms as we expand. So the very first term is going to have a 1 as a coefficient. I then look at the terms within the binomial. I have an x and I have a 3. So every term along the way is going to have x to some power and 3 to some power. And those powers are always going to add up to 5 because in this case we're doing x plus 3 to the 5th. So I'm going to have x and I'm going to have a 3. The power on the x is going to start off at 5. The power on the 3 is going to start off at a 0. And then as we build, those x powers are going to decrease while the powers on the 3 are going to increase. So our next term has a coefficient of 5, and we have an x and a 3. The x, of course, now is going to be to the 4th power, and the 3 is going to be to the 1st power. Okay. Maybe you see where this is going. You might want to pause and see if you can complete this on your own. Otherwise, I'll keep walking you through it. So the next coefficient is 10. And so I need an x and a 3. My x is going to be to the 3rd this time, and my 3 is going to be the 2nd power. As again, you notice the powers consistently add up to 5 as we go through. Next term again is a 10 for the coefficient, and we'll have x squared and 3 to the 3rd. We then have a 5, and that's going to be x to the 1st, 3 to the 4th, and the final term has a coefficient of 1, the last term here, and it's going to be x to the 0th and 3 to the 5th. Okay, so now it's a good time to simplify everything, kind of see what we end up with. I know that anything to the 0th power here, 3 to the 0th or the x to the 0th, is going to give me 1. So I have a 1, and I have 1, and I have x to the 5th. Next term, we have a 5 and a 3, which gives us 15, x to the 4th. Third term, I have 10, and I have 3 squared, that's a 9, so 10 times 9 gives us 90, x to the 3rd. Moving on, I know 3 cubed is 27, and times 10 gives me 270, x squared. I know 3 to the 4th is 81. 81 times 5 happens to be 405 times x to the 1st. And the final term, I have a 1 times x to the 0th, which is 1, times 3 to the 5th, which happens to be 243. And there we did it. We expanded x plus 3 to the 5th without a whole lot of pain. Why don't we try another example? So I'll call this guy example number 1. So we'll call this new one example number 2. I'm going to mix things up here a little bit. This time, I'm going to say a cubed minus b is going to be my binomial. And why don't we take it to the 4th power? Alrighty. Well, something that's useful here, you notice there's a minus in the middle. It's really useful to think of this as a cubed plus negative b to the 4th power. Because then the process that we did up on this problem, it follows exactly the same way, right? So I have 4th power, so that means I'm going to go to the 4th row, 1, 4, 6, 4, 1. There you go. And those are going to be my coefficients. First term has a coefficient of 1, and then I have an a cubed and a negative b. Remember, the powers have to add up to 4 on each of these new terms. So I'm going to have on my a cubed, my power will be 4, and my negative b will have a power of 0. Next term has a coefficient of 4, because we're on the 4th row here, so 4. I'm going to have a cubed, and instead of being to the 4th power, that'll now be to the 3rd, and my negative b will be to the 1st power, because again, each time the powers that I'm putting on these two terms are always going to add to 4 in this case. Next coefficient is a 6, so I take my a cubed, and that's going to go now 4, 3, 2. And the negative b, I had 0, I have 1, so now I have a 2 there. All right. Let's see, after the 6, I have a 4 and I have a 1, so I have 2 more terms. So plus 4, I'm going to have that a cubed to the 1st, and that negative b to the 3rd. And last term, it's a 1, a cubed to the 4th, and my negative b is, oh, excuse me, I just messed up. That a cubed, 4, 3, 2, 1, hey, that should be a 0. 0. And it's the negative b that's to the 4th power. Okay, so let's go ahead and simplify this guy. I happen to know that when I have a power on a power, I multiply those values together. So instead of a cubed to the 4th, that's equivalent to a to the 12th power. And the b to the 0 and the 1, those are just coefficients of 1. Next term, let's see. We have 4 is the only value, the only numeric value there. I'm going to have a to the 9th, 4, a to the 9th. And I have negative b to the 1st, which means I'm going to have minus and a b to the 1st. The next term, I have 6. I have a to the 3 times 2, so to the 6th. and my negative b is squared. So that's going to give me positive b squared. So I'll put a plus here and then my b squared. Moving on, let's see. I know my power on my b is going to be negative, so I know it'll be negative b cubed. So I'll just throw that negative right there. That gives me 4 a to the third, b to the third. And last term, let's see, we have a 1. I have negative b, which is to the fourth. Since that's an even power, I know it'll be positive b to the fourth, so plus. And then a cubed to the 0th, that's just a 1, so plus b to the fourth. And I'm finished. Excellent. Why don't you flip your paper over, and I'll give you another example for you to work out on your own, and we'll see how you did. We'll call this one example 3. And what I'd like you to work out is 4x squared minus 2 all to the 5th power. So go ahead and pause the video, take a moment, and see if you can set this up against the 5th power. So you're going to the 5th row. You have a 4x squared is one term, and a plus a negative 2 is your other term. So take a moment to work that out and then come back and see how you did. All right, so you went through and expanded 4x squared plus negative 2 all to the 5th power. You used the 5th row of Pascal's triangle, which is 1, 5, 10, 10, 5, 1. And then you set up your terms. I actually ran out of room on the paper here. I had to wrap it around. So I have 1, 5, 10, 10, 5, 1 as my coefficients. And then for each term, I have a 4x squared. And you'll notice the powers on the 4x squared are decreasing, starting with the power of 5, 4, 3, 2, 1, and 0. And then I have negative 2 growing from a power of 0, 1, 2, 3, 4, all the way up to 5. Anytime I have an odd power on that negative 2, I know that term is going to be negative. Anytime I have an even power on the negative 2, I know that term will be positive. So I went through and I simplified and expanded. Of course, the power, this 5, would go on both the 4 and on the x squared. So I'd have 4 to the 5th power and x to the 2 times 5, or 10th power. So here's my result. 1024 x to the 10th power minus 2,560 x to the 8th power plus 2,560 x to the 6th power minus 1,280 x to the 4th plus 320 x squared and minus 32. If you got that, excellent. That's a tough one. So keep practicing. I know you'll find that this method is way more efficient and less likely to make errors than multiplying 4x squared minus 2 out 5 times. Keep practicing. See